This paper, Visual Audit Analytics and Visual Audit. My name is Heejae Lee. So in this paper, we try to talk about this new model of visual audit. And in today's workshop, I want to describe how we start this paper and how we develop this paper and what is the model. So in my presentation, I will focus on describing the model and theoretical background. So first, I want to point out what visual analytics mean in this term and in this paper and in the research in general. So visual analytics is not just mere data visualization, but it describes the analytical reasoning that is facilitated by the interactive human-machine interfaces, often transferring into visual format. And this technique combined this automated analysis technique with the interactive visualization. And the purpose of this combination or the combination of these technology is basically to facilitate this understanding, reasoning, and decision-making by the users from the complex and extensive data set. So the visual analytic is not just visualization data as a presentation, but we are focusing on how this visualization can facilitate the reasoning process of the individual, especially in this auditors that perform financial statement audit. So how we started this paper and why that we think was a problem. So it is well known that modern AIS system process extensive and complex business data, accounting data. And that's why there are many ADA or audit data analytics technology proposed in many research and proposed by practitioners sometimes to provide reasonable assurance over the financial statement audit in this complex and rapid changing business environment. Even though there's some advancement in technology-wise, but the problem is the use of ADA is not widespread as we expected, especially in the smaller size audit firm. And one of the reason why this is not widespread is because some of the ADA technology requires some skill set that is not possessed or not trained the traditional auditors are. So there's some gap between this propose of or the design of the ADA methodology and the actual use in practice. And we thought this data visualization or visual analytics can fill this gap because often this use of visual analytics doesn't require as much extensive knowledge as using more advanced ADA technology. And there are several literature describing how this visual analysis can be a powerful tool to make this accounting data sense to the users. And this visual analysis can allow users to create models, specify this visual formats, and gain insight from this massive data set, massive accounting data set without extensive technological background. And one of the benefits is auditor can have more control over this analytical procedure because they can use these visual analytics by themselves without relying heavily on IT specialists to perform this more advanced ADA technology. And for some smaller size firms that have no capacity to develop their own solution for ADA, this visual analysis can serve as a cost-effective solution. Also, this visual analysis can address some challenges in full population testing by facilitating this integration between auditors and complex and large volume of data. But the thing is, this usage of visual analytics is often limited to the presentation rather than actually explore the data. There's even in the recent survey, the data visualization is used in some degree, but it's limited to use of early stage of audit rather than mature stage of audit. So we found like even though there's people tell or they answer they're using data visualization in their work, but data visualization in their actual job is more on the presentation side or communicating the result rather than using that as an analytical procedure. One of the major problem is there's a lack of conceptual guideline or the guidebook of how they can incorporate this visual analytics in ADA in a systematic way, not just doing or creating random visualization to explain what they found. So, and also there is no consensus what visual analysis is and how we can integrate it in the audit process. So that was the problem we had. We work on this visualization outside of this paper as well, but we usually face this challenge from the practitioners on actually using this as a part of their formal audit process because they're not comfortable of using this as audit evidence because there is some perception that visual analytics or data visualization is subjective and often not systematic. So we wanted to come up with some model that allow the auditor to systematically document the finding or the process of this procedure in their audit work paper. And that's how we started this paper. So what we did, so first we realized we need to, we defined what does visual analysis mean in the audit data analysis method as a audit data analysis methodology. And also we defined this tool that can be used in visual analytics in accounting without relying on IT background. And also we introduced this new audit data analysis methodology called visual audit model. And at the end of the paper, we demonstrate this visual audit method using US hospital accounting data. So this part Rocky will take role on this explanation of demonstration. I will focus on explain this concept, how we define this VADA and MVT, and how we design this visual audit model in our paper. So we believe this paper can provide benefit to the research and practitioner, especially because by integrating visual analytics in audit process, we can facilitate AD adoption and practice. And also we can provide conceptual guideline to assist auditors to employ VADA in practice. And also it provides some theoretical basis to design the audit technical solution incorporating VADA. So that's the contribution of this paper. So first I want to describe some definition that we introduced in this paper. So we define this VADA or visual analytics-based audit data analytics by looking into the different literature in audit and visual analytics and data analytics. So in order to fully implement data analytics into the process, not just randomly use the data visualization or use the visual analytics for one or few jobs, the organization aimed to achieve the state of analytical mature or maturity, meaning the state of being complete, perfect, and ready for technological adoption. So they are ready to use this data analytics without any problem. When we call that as a mature. And when the organization or the process is analytical mature, analytics might be automated or at least integrated as a part of the process. And many cases, the self-service solution allow these non-technical users to perform this analytics without coding or extra IT support other than initial setup. So in this paper, VADA refers to democratized self-service ADA supported and facilitated by the VA or visual analytics tool. So that's how we define VADA. So, and the benefit of VADA is instead of emphasizing the technical expertise of the auditors, we are emphasize the auditors' higher orders cognitive skills to understand the accounting data and interpret the accounting data. And we provide a cost-effective solution for audit firms of all size. And also, we believe this can possibly affect the auditor's performance by relieving the stress of dealing with a large volume of data. And that's the benefit. And we describe this. We describe how we describe the detail in the manuscript, and I'm not going to go through today. And we also define what is a mature VA tool. We discussed what is maturity when we discuss VADA. And the mature VA tool is the visual analytics solution that can allow user to perform analytics or visual analytics without heavily supported by the IT professional. And we have this 7 criteria that describe. We look at the different literature to come up with this idea was what this mature visual analytics tool mean in this context of audit. And the example we describe in the paper includes those software solutions such as Tableau, Power BI, Orange3, or sometimes some platform integrating the visual components such as MindBridge AI. Outrex can be another example of this mature VA tools. Anything that have this that qualify as a mature visual analytics tools used to apply this visual audit model that described in this paper. Okay, so next I want to explain this visual audit model, the conceptual model we developed. And this is a brief overview. It's a little bit complicated to look at because there are a lot of components, but I'm going through this individual components in the following slides. But basically, we're trying to describe how this visual audit system can interact with the auditor. The auditor space, the expertise space, is described as a solid line. So this is outside of the visual audit system. This one is describing the auditors or experts who involved in this visual audit process. And the dotted circle describe that the components of the visual audit system. So this is a high overview, and we have 4 different levels in this model. We have visual audit spiral, we have visual audit loop, and we have a visual audit fit, and we have a visual, so we are going to look, we have this visual audit fit, and we have a visual audit space. So I'm going through this whole steps. And to develop this model, we borrow a lot of literature, not only the accounting or auditing practice, but also we bring some literature from the IT or visual analytics, also the user-friendly design or user-centered design literature. And one of the major primary literature we borrow to develop this model is Professor Norman's 7-stage model. So this 7-stage model describes how this product or service or the system should be designed to facilitate the interaction with this product, service, or the system with the users. So it described into 7-stage model. So start with the goal establishment and finish with the evaluation. So we tried to use this concept, but we did not use directly this concept, but we tried to match this model into the audit context. So I'll explain how we embrace this concept in our model. So as we discussed, this model have multiple layers, but I want to explain first what this visual audit loop is. So visual audit loop is the one sequence that starting with the goal space and end with the knowledge space. So basically, they describe how the user or the auditor set the goal to create the visualization and actually create the visualization and get the knowledge from this visualization. And this audit visual audit loop describe one creation of one visualization, and this visual audit loop can be connected to the multiple loop And when there's multiple loops connected to each other, we describe this as a visual audit spiral. So that's how we describe it. And I will go through each of the spaces described in this visual audit loop. So the first one is the goal space. The goal space is the starting point of this visualization. As we discussed, Professor Norman described this design process, the stage of developing the service or system or solution to the user-friendly way. And in this model, we try to incorporate this first three stage of this model. So establishing a goal, forming an intention, and specifying an action. So specifically, establishing goal is described as deciding what is the approach we're trying to take to understand this data. And there are two different paths in this general data analysis approach. One is EDA, the other is CDA. So EDA describe exploratory data analysis, meaning we don't have any predefined hypothesis, but we try to understand what data tells us. So if we don't have any predefined hypothesis to test it, then we go through this EDA path. If there is a hypothesis to be tested, if there is a hypothesis that you want to check whether this is correct, this is right or wrong, then we go through this conformative data analysis path. So depends on whether the goal is EDA or CDA, they will take a different way in terms of setting the audit objective and setting the visualization plan. So after the auditor decide whether they do the EDA or CDA, they set the audit objective to form the intention on what they're trying to do with this data. And audit objective can be broad as the audit objective is testing the internal control or testing the completeness, the more broader scope, or it can be more specific as we go through multiple audit visual audit loop. And this audit objective is directly related to the following spaces, the visualization spaces, system spaces. It will directly relate to the selection of the data or var set. So I'm going to explain what data and var set mean as well. And after we decide the audit objective, we have to decide the visualization plan for this to achieve this audit objective. It includes deciding what type of visual should be used, or sometimes even whether this visualization is the best format to be performed this kind of task. So sometimes visualization can be effective to perform this task. If not, then they will go through the other solution than visualization. This visualization plan step will decide what will be the best format for the user to perform this or achieve this audit objective. So next space is visualization system space. Visualization space is basically the space that encompasses a collection of container for various VA systems. So container are those things that hold a physical or digital representation of different information, such as text, tables, images, or sometimes combination of different file types. And we can describe this visualization system into three different pieces or three different types of container, the data, var set, and visual. So data in the context of visual audit refers to as a data of interest. The data the user or auditor are interested in. For example, if the auditor wants to look at the accounts table and the transaction table to look at whether there's a discrepancy between the account table balance and the actual total of the transaction table, then we will have to use both accounts table and transaction table, and that can be described as a data for this visualization system. But we're not going to use every single instance or every single column in this accounts table or transaction table. Depends on what is your audit objective. You have to take the subset from this data. And that is described in the second component of the visualization system space, which is a var set. So var set can be described into two different types of categories, variables and instance. Variables are those characteristic of those data, often described as a column, and the instance are those individual record or individual facts that is related to the data. For example, the variable out of this accounts table and transaction table, you can take out the total charges to the customer or patient and the total number of transaction or total volume of the transaction as a variable, not taking every single column or every single data field from this data set. Instead, you can pick up certain variable you want to create a visualization to achieve the audit objective. And the instance are those records you are trying to visualize in your visualization. For example, you might take all the population as a whole, or you can take certain type of account, transaction or certain type of data. For example, if you're only interested in accounts where the balance equal to 0, then you can only filter out those instances to create a var set. So that's the difference between the variables and instance in the var set. When next component is the visual, and visual is describing the three different components in this model: graphical object, visual variables, and guide. So visual object is the characteristic, whether this is a bar chart, line chart, pie chart. So how this object is graphically presented in as a visual. The visual variable, on the other hand, describe how this visual create the difference, create the analytical procedure. For example, sometimes the difference can be measured as a size of the bar. It can be difference can be distinguished as a color of the bar. Or sometimes it can be the it can be the gradation of the color, gradation of the bar. So depends on the visual variable. You can create a different type of visuals. Guide is providing the extra additional information to the user on top of the visual, the graphical object or visual variables. For example, you can put some label to provide extra information to the users, or you can use color legend to show, provide information how what is the color is meaning in this graphic. So we distinguish this into three different categories in the visual. So, so these two spaces I described earlier, the goal spaces and the visualization system spaces, have this middle ground called interactive action spaces. So the goal spaces and also the actual auditor, the expert spaces, will be interacted through this space called interactive action space. So when they create the visualization to achieve the objective or achieve the goal of this process, they will go through this interactive features. So the auditor will actively involve in this process, and they will interact with the data and interact with their knowledge. So, this interactive action spaces described into three major components: data preparation here. The data preparation is the first interactive space component. We have var set creation as a component and the visual operation as a component. And data preparation is basically how this data is of interest is prepared from the raw data that exists in the AIS system. So it can describe in a three-step: connect, clean, and shape. And the var set, after we get this data, the data is prepared, we will create a var set, go through different type of steps. We describe as a import, search, filter, regenerated, and abstract and elaborate. You can find the detail on what this means in the paper. And the last component is visual operation, how this var set is converted into visual and through the different process. And for the mature VA tool we describe in this model, sometimes this process can be automatically converted or automatically completed by the solution. So for example, sometimes this FARSA creation can be done automatically by the solution, or such as Tableau or Power BI, automatically provide what is the best visual format and just create their visual format. Sometimes the auditor can manually decide what they believe bar chart is the best way to create the visualization, to demonstrate this visualization, then can decide to create a bar chart instead of line chart. But in many mature visual analytics tools, this can be done automatically, and that is described in this auto completion action space container here. You can see the visualization recommendation or automatic visualization as automatic completion action. Also, sometimes they can have automatic sampling and data mining as a background of this interactive action space. And the last space of visual audit loop is the knowledge space. So after they create a visualization, at the end of the day, they have to acquire information from this visual result. And this knowledge space describes this process. And we not just to describe this knowledge in a more systematical way, we describe into three different pieces: finding, insight, and hypothesis. Finding describe specific observation derived from graphs. So finding doesn't require knowledge about the domain. For example, you can have a finding of, oh, the green bar is longer than yellow bar. So finding is what you can derive or what can acquire from the graph itself. On the other hand, insight require the interpretation of the auditors. It required the domain knowledge. For example, if the yellow bar represents the revenue of the last year and the green bar represents the revenue of this year, and there is a huge change from last year to this year without any change on the business in general, then it can you can flag the auditor about maybe there's something going on behind this. So the insight require this interpretation, as we discussed in the Norman's model. The stage 5 is described in this finding process. Finding basically just perceiving the state of the system. On the other hand, the stage 6 is involving interpretation of the system. So what this mean in the real life? What this mean? This visualization telling us about this data and what actually happened behind this data. And also this involving after you get the insight, sometime you will go through another visual audit loop when sometime you didn't find anything that make you to build a hypothesis and you need another exploration. Then you go through the first path. You just go for developing another goal and perform another EDA. Sometimes you can build a hypothesis based on this insight. You want to test this insight. Then you go through this next visual audit loop to go through the CDA process. Other time, if you think this insight is good enough to be documented, or this insight can be just completed as the one audit objective, then you can collect this insight, and this insight will be collected from the different process, and this will be documented as an audit evidence. So that's the knowledge space. And so as I mentioned, so this visual audit loop can be done as more a sequence rather than one visual audit loop as an independent process. So sometimes you have to go through multiple visual audit loop to get the desired level of assurance about the information you collected. Then you go through this multiple loop, loop number 1, loop number 2, and loop number 3, sometimes loop number 4. When you arrive at this desired level of assurance, then you'll stop and you will prepare the audit work paper based on the findings. And all these containers and all these steps we describe in this model can be used as a documentation for the audit as the audit evidence. And let me make it. So this is an example of visual audit loop. You can see we have 3 different loops. I will not go through individual detail right now. I think Rocky will explain in the demonstration. But so we try to, so it's not like just one visualization. The creating visualization, you find something that's, and you just stop there. This visual audit model try to explain how this analytical process of the human or auditor can be systematically help user to go through, arrive in some conclusion and collecting the evidence. And this can be systematically documented in the audit work paper, not just a snapshot of the visualization. And that's the whole point of this paper. We're trying to make this as a more systematical approach that can be applied in the practice. So we wanted to define this concept so they can use this as a evidence, actual work audit ADA process as a part of their audit work. So that was the idea. And we also look into this visual audit fit. It described the interaction between the expertise space and the goal space and visual audit system. So always it's important to look at the fits between the goal and the visual audit visualization that created. So we described this how what are the things that should be considered. For example, what depends on how much graphical literacy the user had. The best visual format to be used can be different. Also, the IT knowledge of the auditor can decide how this visualization system can be generated to achieve the visual audit goal. So that's in this visual audit fit stage, we try to explain how this can be systematically disclosed, considering those fits of the users.